Hi guys. Okay, so I've decided to do a couple of videos myself. Hopefully it's not too boring, but the first thing I'm going to look at is a function of a function uh, for uh, for P9 to help you with P9. So if you open your, or you can just follow if you like, but just make sure you have at least your standard derivative sheet or something open. So if you want to pause the video and get that so you can follow what I'm doing, and I'll be looking at the questions on page 66 of the workbook. I've done this with probably all of the classes. Yes, I've done this with all of the classes, but I'll just go through it again as a recap. Um, so we have number one, sorry. Number one says y is equal to 2x minus 1 to the power of 6. Now we've got, why it's called a function of a function is because you've got this part here is a function that can be the derivative can be taken. This derivative, you can take the derivative of that function, and you can also take the derivative of this function together with that. And that's where our u comes in, if you can remember. Remember I said let u be equal to 2x minus 1. Okay, so we basically let u be equal to one of the functions that we can take a derivative of. And then, so if u is now equal to 2x minus 1, then y becomes u to the power of 6. U to the power of 6, because we've now allowed u to be equal to 2x minus 1. Okay, and now, if u is equal to 2x minus 1, now we have to take the derivative of u, the derivative of u with respect to x, and to do that, we look at the second rule on our sheet. So if we go, can I look at? It's a second rule at the from the top, which says, let me just write that down for you here. That says a x to the power of n. If you take the derivative of that, that becomes a n x to the power of n minus 1. Now this a, this a is that a, and another color, this n, and that n is this n. Okay, so whatever these numbers are is what these numbers are here, or these variables, or whatever you want to call it. So if I have a x to the power of n, looking at my function here, I've got, and we only look at one term at a time, hey, only one term at a time, we don't combine them. So we look at 2x, so now we have 2x, and if we don't see the power, as you know, the power is 1. Okay, if we now take the derivative of that, we multiply, this means multiply a by n. So that means this is now your a, and that's your n. So you multiply, so a is 2 times n is 1, and then we write down the x, and n, which is 1, minus 1, because the rule says deduct 1 from n. Okay, and this then becomes 2 times 1, which is 2. X to the power of 1 minus 1 is 0, and you should know by now that anything to the power of 0 is equal to 1, and that gives us 2. So this derivative here, the derivative of 2x is just 2. And then when we come to the minus 1, You should know by now as well that the derivative of a constant is 0. Okay, so they just disappears. The minus 1 just disappeared. You don't write 0. Please don't write 0. Okay. Now we look at this one. Now we take the derivative of y with respect to u because we now have y and u. And this u, you can just imagine it's x on your sheet. And your sheet says, your sheet's got these different colors. Okay, your sheet says x to the power of n. If you take the derivative of that, that becomes n x to the power of n minus 1. It's exactly the same as the rule above. The only difference is we don't have the a in front now, or our a in front here is just 1. Okay, but the rule says take the n to the front. There it is. That's an n. Sorry, it's not a u. It's an n in my writing. And then deduct 1 from the power n minus 1. Okay. So instead of x, we now have u. And instead, well, our n is now 6. Okay, and the rule says, okay, so take the 6 to the front, u, and deduct 1 from the power. 6 minus 1 is 5. Okay, so dy du then becomes 6u to the power of 5. And the rule says, if you look on page 65 in your workbook as well, it says dy dx. That means if you look at this function and we want to take the derivative of that function, we need to multiply dy du by du dx, and inherently this means that let me get another, not that dark. This and this basically cancels out, but we're not going to do it. It just means that this is legitimate. I can use this. Okay, and then so we say, so dy du is now equal to 6u to the power of 5 times du dx. Du dx is equal to 2. Okay, but we want dy dx. We don't want u in our equation here. It would not be right. So what we do is we go back and we say, okay, what did we set u equal to? We set u equal to 2x minus 1. So we have to put that back as 2x minus 1. And don't forget the power of 5 times 2. And that then gives us 6 times 2. Let me just write here, dy dx is now equal to 6 times 2, 12. 2x minus 1 to the power of 5. And that is the answer.